All right, let's use Pascal's law to explain why when Pat stands on the small cylinder of this hydraulic lift, Pat goes down and the car goes up, even though Pat's a lot smaller than the car. Let's start with what we know. We know that force is equal to pressure times area. Pressure then is equal to force divided by area, and if we manipulate the formula once again, we get that area is equal to force divided by pressure. Pascal's law states that changes in pressure at any point in an enclosed fluid at rest are transmitted undiminished to all points in the fluid and act in all directions. Let's see what that means. Let's say Pat has a downward force of 200 pounds. He's exerting that force over an area of 2 square feet. Using our formula for pressure, we know that the pressure that is induced in the hydraulic fluid is 100 pounds per square foot. Using Pascal's law, we know that the pressure is going to be transmitted undiminished to all points in the fluid. Well, that means that the pressure over here is going to be the pressure over here, which is the pressure over here. Any point in this hydraulic system, the pressure is going to be the same, which is a force of 100 pounds for every single square foot. If you notice, the area of the second cylinder, the large cylinder, is a lot bigger than the area of the first cylinder. So if every single square foot has a force of 100 pounds, that means that this larger area will end up having a much larger force. Let's say we need a force of 3,000 pounds in order to lift this car. We can plug our numbers in order to figure out what area that second cylinder needs to have in order to lift the car. So we just plug in our information. The force that's necessary is 3,000 pounds. The pressure we already know is 100 pounds per square foot. So we're able to figure out that the area of that second cylinder needs to be 30 square feet in order for the hydraulic lift to work.